Chapter 4, Lesson 7, Linear and Nonlinear Functions. You will be able to determine whether a function is linear or nonlinear. Linear functions have graphs that are straight lines. They have a constant rate of change. Nonlinear functions are functions whose graphs are not straight lines. They do not have a constant rate of change. An easy way to remember what linear functions are, if you look at the word linear, it actually has the word line in it. So linear functions are straight lines. Nonlinear would be not straight lines. So in order to determine if functions are linear, we need to find a rate of change. So to do that, let's find our change in our y values and the change in the x values. So from 50 to 35, it's minus 15. From 35 to 20, it's also minus 15. 20 to 15, or 20 to 5 is also minus 15. Your x values, from 2 to 4 is plus 2. From 4 to 6 is plus 2, and 6 to 8 is also plus 2. So our rate of change is our change in y over change in x, which would be negative 15 over 2, or negative 7.5. So because this has a constant rate of change, it is linear. So, linear because the function has a constant rate of change. That is our answer and the explanation. Letter B. Our y values from 1 to 16 is plus 15. From 16 to 49, it's plus 33. From 49 to 100, it's plus 51. On the left-hand side, for the x values, from 1 to 4 is plus 3, 4 to 7 is plus 3, and 7 to 10 is plus 3. I cannot find a rate of change because these numbers are all different. I wouldn't know which numbers to use. So, this function is nonlinear because the function does not have a constant rate of change. Letter C. Our change in our y values from 20 to 16 is minus 4. From 16 to 12 is minus 4. From 12 to 8 is minus 4. Our x values from 0 to 5 is plus 5. 5 to 10, plus 5. 10 to 15, plus 5. So our rate of change is the change in y over the change in x, which is negative 4 over 5. We could change that to a decimal or just leave it as a fraction. Because it has a constant rate of change, our function is linear. Letter D. Our y values from 0 to 2 is plus 2. From 2 to 8 is plus 6. From 8 to 18 is plus 10. X values 0 to 2 is plus 2. 2 to 4 is plus 2. 4 to 6 is plus 2. I can't determine a rate of change because I have different numbers that the y's are increasing by. Therefore, this is nonlinear because the function does not have a constant rate of change. Use the table to determine whether the minimum number of calories a tiger cub should eat is a linear function of its age in weeks. We're still going to solve this the same way. We'll do our age over here. It doesn't matter which one you do first. From 1 to 2, 2 to 3, 3 to 4, 4 to 5, these are all increasing by 1. 825 to 1,000 is increasing by 175. If you're unsure what it's increasing or decreasing by, you can actually take the bigger number and subtract the smaller number. So 1,000 minus 825 is 175. 1,185 minus 1,000 is 185, and so on. So 1,185 to 1,320 is plus 135. And 1,320 to 1,420 is plus 100. It does not have a constant rate of change. Therefore, the function is nonlinear. So nonlinear because the function does not have a constant rate of change. Letter B. Tickets to the school dance cost $5 per student. Are the ticket sales a linear function of the number of tickets sold? Explain. Our number of tickets sold, the change is plus 1, plus 1. The ticket sales, plus 5, plus 5, which would mean our change in y over change in x would be $5 over 1, or $5. So because I can find a constant rate of change, I know my function is linear. A square has a side length of s inches. The area of the square is a function of the side length s squared. Does the situation represent a linear or nonlinear function? Explain. So let's pick some side lengths for a square. 1, 2, 3, 4, and 5. Now, if I had side lengths of 4 or of 1, to find the area, it's 1 squared. 1 squared is 1. If I had 2, 2 squared is 4. If I had 3, 3 squared is 9. 4 squared is 16. And 5 squared is 25. From 1 to 2 is plus 1. 2 to 3 plus 1. 3 to 4 plus 1, 4 to 5 plus 1. The areas, 1 to 4 is plus 3, 4 to 9 is plus 5, 9 to 16 is plus 7, and 16 to 25 is plus 9. This does not have a constant rate of change, therefore the function is not linear. So nonlinear because the function does not have a constant rate of change. A square has a side length of s inches. The perimeter is a function of the side length for s. Does the situation represent a linear or nonlinear function? Explain. So again, I'm going to pick side lengths of 1, 2, 3, 4, and 5. But this time, to find perimeter of a square, you multiply the side length by 4. So 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and 4 times 5 is 20. The change from 1 to 2 is plus 1, 2 to 3 plus 1, 3 to 4 plus 1, 4 to 5 plus 1. The change from 4 to 8 plus 4, 8 to 12 plus 4, 12 to 16 plus 4, 16 to 20 plus 4. So the rate of change would be 4 to 1, or 4, which means it has a rate of change, which means it is linear. Graph each function by making a table of ordered pairs. Determine whether each function is linear or nonlinear and explain. Well, we've done these tables before. Your equation goes in the center column. And let's pick some values. We'll do -2, -1, 0, 1, 2, 3. Again, I like to choose some negative numbers, positive numbers, and 0. Plug them in. Well, this -2. This negative sign over here has to come down, but this number is also negative, so you will have a double negative there. Plus 1. A -2 is a +2. Plus 1 is 3. Plugging in -1. -1 is 1, plus 1 is 2. 0. -0 plus 1. You can't really have a -0, so it's really just 0 plus 1, or 1. -1 plus 1 is 0. -2 plus 1 is -1. And -3 plus 1 is -2. So now let's plot these points. -2, 3. -1, 2. 0, 1. 1, 0. 2, -1. And 3, -2. Let's make those points a little bit easier to see. Now these do appear to be in a straight line. Let's draw a straight line and see where it takes us. It does, in fact, create a straight line. So this function is linear because the function is a straight line. Letter B. So our function again goes in the middle. Y equals -9 over x. Pick some values. -2, -1, 0, 1, 2, 3. So -9 divided by -2 is positive 4.5. -9 divided by -1 is positive 9. -9 divided by 0. If you were to plug that in your calculator, let me just show you what happens. The answer is not 0. So -9 divided by 0, there's an error. It says, on this calculator, it says cannot divide by 0. Sometimes your calculator will say different things. It'll say error divide by 0 or other reasons. You cannot divide by 0. This type of number we refer to as undefined. So whenever you have 0 in the denominator or you divide by 0, it's considered undefined. So there really is no point there. All right, let's plug in 1. -9 divided by 1 is -9. -9 divided by 2 is -4.5. And -9 divided by 3 is -3. Now in this graph, I'm actually going to count by 2's here. So 2, 4, 6, 8, and negatives. -2, -4, -6, and -8. And left and right, I'm going to count by ones. And I want to mark them just so it's clear what we're counting by. If you were counting by ones, you would not have to mark them at all. But since I'm counting by ones left and right and by twos up and down, I want to make sure I mark these. Okay. Okay. So -2 and 4.5 is about here. -1 and 9. I can't plot anything for 0, so leave it be. 1, -9. 2, -4.5. And 3, -3. Okay, now you can see as well as myself that it is not a straight line. You may not know how to graph something like this, but knowing that whether it's a straight line or not is really what you're learning here. I will graph it so you can see what it looks like, but before I do that, I will say this is nonlinear because the function is not a straight line. And let me graph this here for you so you can see what it actually looks like. It'll actually curve like this, and the same on the other side. That's what it actually looks like. Again, I don't expect you to know how to graph something like this type of function, but you should be able to recognize if it's linear or nonlinear. And in this case, it is not linear. Those dots did not line up in a straight line.